All right, so hello everyone. Hopefully you can hear and see me. So welcome. Okay, you you are seeing me. Welcome to this session 2, which is titled as Data Intensive Science and Connecting through Arctic Region. And I'm hosting this session. I'm Pekka Uusitalo, Partnership Director here at CSC in Finland, and also the member of NORDUnet board since 2018. And we have here 2 very interesting presentations coming up, and I will shortly introduce the speakers. But also here you can post the questions to the pigeonhole, and we will cover some of the questions, as many as we can, at the end of the presentation, so after the second presentation. So we will start with Per Öster, and Per Öster is working at CSC as Director for Business Insight and Growth, and he has a long experience of various research infrastructures in Europe and worldwide. And he will dig into this data incentive science topic. As we heard from the Stefan Woodbers, the data is the new oil, and that also is relevant in the research domain. And I will hand it over to Per, and then I will introduce the next speaker after Per's presentation. So Per, the floor is yours.
Okay, thank you. I hope the sound is okay. I'm speaking from a pigeonhole. It looks, feels almost like. I try to share my screen here to get started. And so data intensive science connecting through the Arctic region. So I try to get my things in order here. Yes. So I will not comment if the data is the new oil or not, but oil is probably something that we should stop to use, but data we should use more and more, and you will see that this is also what happens. I will start maybe to state something that is today obvious with a quotation. But almost everything about science is changing because of the impact of information technology. This quote is from 2007, very late, it feels to me, and from a speech by the late computer scientist Jim Gray, who spent a lot of thinking of this, what about data and how to use data in research. And a lot of things have been changing here due to information technology, particularly the rapid development of sensors, network technology, computing capability and capacity, and new methods to extract knowledge from data has made research data-driven to previously unsurpassed extent. The omnipresent collaborative essence of science has today been further enlarged in the concept of open science. Science has always been collaborative, but today we talk about open science. In the 2012 report from the Royal Society, Science as an Open Enterprise, recommendation number 1 starts, scientists should communicate the data they collect and the models they create to allow free and open access in ways that are intelligible, accessible, and usable for other specialists in the same or linked fields wherever they are in the world. So is open data and fair data more or less defined today. We talk a lot about fair data, which stand for findable, accessible, interoperable, and reusable. It took its step in this and led to a lot of work. And then we had to talk about what is the data life cycle in research. With data in focus, the generic concepts of the use of data in research has to be understood. Plenty of efforts and more or less elaborate. Now my slides are running amok here. So plenty of efforts and more or less elaborate models have been put in place. Corresponding services has been developed, and most research funders require data management plans today by their applicants. Research data is not only collected and analyzed, metadata is created to allow sharing and reuse, persistent identifiers are attached to allow identification and citation. Decorated in this way, data is not only data, but become digital objects to be shared and reused. And in addition to this data and the services that we provide today around data, research is very much about workflows. And I challenge you to find any research that cannot be described by a workflow. Particularly with the data-intensive research, also workflow tools are needed to facilitate the often many steps in combining network geographically separated resources of data repositories, computing clouds, visualization equipment, preservation service, and you name it. So, and here you see an example how research typically happens. A couple of guys come together, taking the paper or a backside of the paper. Ideally, it should have been a napkin, but this is a reuse of a paper. Sketching what should need to be happen, and this is an actually complex workflow combining supercomputing data resources from different countries and places on the globe. And this is what is also happening here in the Nordics. In all this combined, the use of data, the open science, the open data, and the workflows has led to a fantastic development where not only the large-scale research facilities produce enormous amount of data, but we now have a large number of distributed research infrastructures from all the areas of research that can be combinations of sensors, data and compute resources, research area specific services, all facilitated through workflow environments. The Nordic countries host a number of facilities and are involved in a large number of distributed infrastructures. For example, we have facilities like IceCat 3D, which is under construction. It's a phased array radar system for study of the upper atmosphere and space environment, with emitters and receivers placed in the very north of Norway, Finland, and Sweden. It is a very special system where the actual network will become an integral part of the research infrastructure. You will hear more about this later today, I should say. I will not talk more about it, but other speakers will come. MAX 4 is the new and world-leading synchrotron in Lund, Sweden, producing the brightest X-rays to study material structures down to molecular level. With this new generation of bright synchrotron light, the resolution is increasing and, of course, amount of data produced. A dedicated supercomputer center in Denmark will take care of this. European spallation source, also in Lund, the neighbor to MAX 4, is a neutron source that also can be used for study of matter, with a big advantage of being non-destructive for the studied objects. Coming to that was the facilities. Coming to the distributed infrastructures, we can start with language research and Clarion. Connecting language resources and services in the Nordic countries and rest of Europe, it has become an indispensable, enables researchers from all around the Nordics to use most advanced environments for most advanced tasks, such as natural language processing. Experiments can also be distributed. One example is the sensor networks used in atmospheric research, here represented by the smear measurement stations, partly placed in very remote areas, but constantly collecting data and distribute data to be analyzed and used by the research infrastructure, such as the Carbon Portal ICOS and ACTRIS, the aerosol clouds and trace gases research infrastructure. Elixir is a distributed infrastructure for bioinformatics, connecting hundreds of institutes around Europe with very strong contribution from the Nordics. Combining core life science data resources with supercomputing and advanced services with very complex workflows, expecting it to shovel data through the network without hesitation. Last but not least, next year, EuroHPC Lumi supercomputer will arrive in Kajaani, Finland. The 10-country consortium with European Commission initiative will establish one of the fastest and most advanced computing resources in the world. It will not only produce enormous amount of data, but will also be a magnet for huge data collections serving all areas of research. As you understand, these are only few of the many examples of research infrastructures with Nordic participation. And you see a list here of all the different infrastructures where we have Nordic participation and location. It is a strong inherent trend when more and more of research become big science or managed as big science. As the capabilities of research are increasing, the societal demand on research is also increasing. Just the present situation with COVID-19 has showed how dependent society is on research. And I think it has been proven that with the advanced infrastructures we now have based on knowledge built with decades of research in many ways capable, research is in many ways capable to meet this demand. Thank you.
All right, thank you very much, Per. As we are hearing, data is really dominating the environment we are living and doing research work in. And let me now then introduce the next speaker. He's Olaf Schjelderup, and he's working as a director of core networks in Uninett. And we are going to hear now that what is the role the network connectivity will play here, and especially in the Nordics and Arctic region. So please, stage is yours, Olaf.
Thank you very much, Pekka, and thank you also for the honor and opportunity to give a speech at this very nice day celebrating NORDUnet being 40 years. So I will dig a bit into the network part of what NORDUnet is doing. So first I will ask the question that many people around, directors at universities and politicians and many people ask, what is really research networking? We do have the internet, don't we? Well, there is actually a huge difference, but also many similarities. I would say first, the entrants are a huge part of the global internet, but we also are much more. What we, as we heard Per just said, advanced research often demands extremely high capacity, network capacity, but not only within a country on a short distance. The requirements are globally, and this is where the hard part begins. The traversing multiple national networks, it will require extensive collaboration and coordination. So our business is much about removing bottlenecks, looking for reducing the latency and acquire better networks paths. And fiber infrastructure may be expensive, so we have to be very clever acquiring infrastructure, but also understanding the problems we will help to solve, engage in the research and really understand what are the research areas that our customers are working with. And of course, being a global community that collaborates a lot, there will be good ideas for new digital services. And we have plenty of examples during all those years. Eduroam is one, video and media services, cloud services. So given these challenges, I would say the good news here is entrants are particularly good at the above. We have been working, and NORDUnet has been working for 40 years with this. And as also Per indicates, the data explosion is here now. There will be more of this. So this picture from CERN, it has 10,000 fiber cables within, a technician told me. And the prognosis says, well, within a couple of 3 years, we need 4 terabits transported around the planet to various storage and compute facilities. That is challenging. So let's see if my slide will change here. Yes. So what is going on in the present? You see a map showing the NORDUnet network here, and behind in the layer under this network, we have the entrance, which are very well crafted network, both now and will be in the future. And building the new NORDUnet network, well, we started at the NORDUnet offices in January 2018 and gathered the Nordic network expect. What are our objectives and how should we do this? So we stated some principles that we will reuse existing and coming optical infrastructure within each country. And we also stated some principles like high availability on this network. Well, it starts with the number 3 in any sense. And no country should not be single dependent of just one other country. And that is more government requirements, but we were able to fulfill them as well. So personal experience, it was very good to be in this collaboration party, I would say. It was Nordic collaboration at its best. And as we see here, and also from Per's presentation, good network, extremely good network, is a prerequisite for research infrastructure. And LUMI is also about that. We don't see LUMI at this map because the last 10 folds of miles to LUMI is provided by the optical network of Uninett. So what we see here, NORDUnet has been in the forefront for 40 years, and we also recognize NORDUnet has been a great example for other entrants globally. So what is the innovation? Yes, a couple of years ago, or many years ago, 5 or 6 years ago, the iSCAT 3D radar, atmospheric radar, was planned. And one was by then looking for a traditional solution, connecting Skiboten's antenna radar and the Kaisiniemi antenna and the Kaarisuvanto antenna. And one could foresee 100 gigabits per second with the compute and storage at each site. Bringing together the scientists and the network engineers, one came up with a new different solution, making the antenna in which are distributed and the network let the network be an integral part of the research instrument. So now we are looking at 8 terabits within a year or 2 provided in this ring. This is really innovation and disruptive innovation because it changes how science is done. We are streaming a lot of information from this antenna to the compute facilities at Skiboten. So this is, I think, in many areas, the new way much advanced science will be done in the future. So what's next? What's the next innovation here? The Finnish company, telecom company Cinia, has for a long time been working on and planning and a pioneering subsea cable from Kirkenes in northern east part of Norway to Asia and North America. And NORDUnet came in touch with Cinia, and is now, with support of Jean, taking the lead in providing nothing less than global terabit research and education connectivity through the Arctic region. So our goal here is, of course, much better connectivity and a path to North America and Asia. And our goal is one dedicated fiber for research and education. And one dedicated fiber means a lot of capacity. This will radically increase global network capacity, not only Nordic, Asia, but globally, and resilience. And calculations shows much lower latency figures, for instance, between Stockholm and Seattle, Stockholm and Tokyo. And one interesting thing that is very strategic about this cable will move, let's say, the network gravity center in Europe northwards. And it's also very strategic that transit traffic and transit networks through the Nordics will lead to investments. It always had. That's many stories around the globe shows providing networks, things start to happen locally or regionally. We think there will be more data centers here. And that the reason for that is the energy is very green, much hydropower, and there are much surplus power in the northern region, and it's low cost. And of course, there are natural cooling. This will, of course, lead to more fiber infrastructure and more opportunities for advanced research. So what do you call this strategic thing? Well, we made a name of it, called it Gravity North. Seeing the Arctic cable here landing at Kirkenes, and the traffic streams are flowing up and down the Nordic countries. We think, well, Lumi is happening now. This is fantastic. We think there is interesting for another Lumi in the next round because of the reason mentioned. We also believe that this will be a success, that another Arctic cable, within a few years, that idea will seek to happen. And of course, all this interesting research, which is where the Nordic region have special advantages. For instance, volcanic research at Iceland. Yes, there are a lot of activity underground going on here. And we have in Onsala, Sweden, and Ny-Ålesund, Svalbard, the VLBI stuff going on, monitoring quasars 200 million light years from the Earth, and synchronizing the GPS clock with actual time. So being at Svalbard and Ny-Ålesund, you can look over the North Pole and you can correlate with signals from Australia. And of course, the Arctic region is very interesting in a climate research perspective, both in the ocean space and the space above us. Pierre mentions the ESS and the MAX 5 crossing both Denmark and Sweden. And in the northern Norway, in this area, a new rocket launch facility for research is being built, not far away from I come from, at Andøya. And there is also one in northern Sweden, S-range. So I think we have very exciting times ahead, and the new federated network and the idea of Arctic cables will pave the way for us. So thank you.
All right, thank you, Olaf. We are running a little bit short of time here, but let me just raise one question for Per and one for Olaf. So, question to you, Per. There's a couple of votes behind that. Do you think that the use of large amounts of data is financially sustainable in research in the longer run?
Interesting question. Financially sustainable, if one think about what is I mean, there are several costs, of course, research costs, and large-scale research is costly. But one also have to think about the gain. And of course, data is costly in the sense for storage, and especially if you go to preservation of data. So there, I think it will be, I mean, that we see also in most countries now, when you start to think about the preservation, what data is the thing that you need to store for, I mean, forever, what that ever means in digital world. But there a selection need to be done. You can't just store everything, probably, at least not right now. But otherwise, I don't see this as an issue. Like any cost for society, it is weighted towards what you gain. And I mean, we see now, as my final words were there with COVID-19, and how rapidly, for example, research have been able here to respond to a societal need in terms of vaccine and understanding of what this virus is about. I mean, the cost for that research is, and we see the losses for society for every week we have to spend in this condition, under these special restrictions and so on. It's almost negligible. Yes.
All right. Thank you for the answer. And then one quick one for Olaf regarding the networking side. There's a question asking that what, if any, data-aware functions do you see need to be supported in network in the future? Data transfer nodes, AI, machine learning, privacy functions, and how can the network become smart towards your applications? So let's have a very short and condensed answer to this one.
I guess that requires a couple of hours. Let me focus on one thing. Latency is important regarding a network performance or performance experience. So I think short-traveled data storage is one important thing we need to look at. Moving a lot of data over long distance is hard, requires a lot of buffers. So I think bulk data storage and network engineering are very tied together. But there are of course a lot of other issues here to look into, and yes, but I think we need a whole conference on that.
All right. So it's time to close this conference. We are not going back to the plenary room. So thank you very much for everyone joining this research track. And I wish you a very nice day, very nice evening, very nice night, wherever you are. And stay safe, and we'll see you again. Thank you very much. Bye-bye.
Bye-bye.
Thank you, and congratulations to NORDUnet.
Congratulations.